Good afternoon, everyone. Welcome to today's webinar discussing particulate blocking hoods. My name is Matt with the National Volunteer Fire Council, and I'll be your host. Before we start, I'd like to let you know that we'll have a short question and answer session following the presentation. Today's presentation will also be recorded and will be available in our online classroom that can be reached through nvfc.org. After the Q&A, we'll be announcing the winners of the particulate blocking hoods that were generously donated by our partner in today's webinar, W.L. Gore Associates. Today's presenter is Jeff Jury of W.L. Gore Associates. Jeff has served in the various strategic marketing and business development roles in the chemical industry over the last 25 years and holds degrees in biology, chemistry, and business administration. Jeff, take it away.
Good afternoon. Today we're going to talk a little bit about this new category of particulate blocking hoods, and I'm going to try to give you some information that will aid you in evaluating the multiple choices that are out there. So this is sort of the picture that started it all. This photo was from a study conducted by the International Association of Firefighters in 2015, and it highlighted an area of risk that I think a lot of firefighters were sort of aware of, but this sort of clarified it in people's minds. This is called a FAST study. I'll talk a little bit more about that study later in the presentation, but the glowing areas of this photograph represented particulate penetration through a standard hood. So it sort of sent out an alarm bell that created a very fast-moving category of products and concerns. So basically, why do firefighters wear hoods? And what are the reasons that you would choose a hood? First of all, most firefighters want to make sure it meets the NFPA requirements. Secondly, you wear it for thermal protection. Third criteria is it needs to last. And then this new one that we're expecting hoods to do, which is provides protection and has barrier properties. Then after we meet those criteria, we would say, well, does it fit and does it breathe? The performance, thermal protective performance measure right now, just so we go back to number 2 requirement. For hoods, it's a minimum of 20. The current turnout gear you're wearing, the garments, is 35, just for perspective in terms of the protective layer of hoods, or protective factor of hoods. So what's changed with hoods? Well, with increasing concerns about the fireground particulates and skin absorption, the NFPA 1971 committee decided to add an optional hood category in the 2018 edition of the standard. The primary feature of particulate hoods is to block particulates. Blocking layer is not a moisture barrier. It will not provide common chemical or viral penetration resistance. And the reason that they didn't require it to be a moisture barrier is the NFPA recognized that if you required it to be a moisture barrier, then it would limit the technology options that were available in terms of meeting breathability requirements and other requirements that a hood needs to have. So why did they pick these particulate ranges? The standard specified specifically that the hood must block particles between the size of 0.1 microns and 1. Why did they pick those categories? Well, likely if it met that criteria, it would block larger particles. If it was smaller than that, the particles would have insufficient mass to push themselves through a hood. So that's why there's been a lot of questions about that. That's why that particular range was chosen to be the standard for the testing. So how is it tested? Well, the NFPA standards particulate blocking test, again, there's the range of particles that are tested. The composites that are used in the hood are preconditioned with 20 launderings and 2 convective heat cycles for 10 minutes. They're placed in the, a sample is placed in the equipment shown in the right-hand picture, where it's then connected, and positive airflow is pushed through the barrier. The particulates being pushed into the barrier are measured the amount, and then the amount on the other side of the barrier are measured. The requirement is that it block 90% of those particulates in that range of 0.1 to 1 microns. So that's how the test is run for particulate blocking. Before we proceed, I want to make a point, because there's a lot of confusion sometimes about air permeability and breathability. They're not the same. Particulates with higher air permeability can allow more air and particles to travel inward, which could decrease protection. Breathability is the measure of a material's ability to allow water vapor to pass through. So one is air and one is water vapor. Evaporation of sweat off the skin as water vapor is the primary cooling method for the body. So you need to have good breathability and a high particulate blocking efficiency to balance that measure of cooling through evaporative cooling and protection from particulates. Now, the reason I covered that was I want to talk about a little bit about breathability in warmer conditions. There's a new measure called RET, which has been recommended by the NFPA 1971 task group for the next revision to the standard to augment the measure of THL. And if we look at, the question I'm trying to answer is, are these hoods going to be warmer than our traditional hoods? If you look at station wear, you can see it's around 7 on the RET scale. A traditional hood is somewhere between 7 and 10. The hoods we've measured, which of course are our hoods, are around 13 or so. And just as a comparison, you can see that turnout gear with the Gore Crosstech Black ranges, depending on the outer shell and the other parts of the gear that's combined with our moisture barrier, range between 22 and 35. In this measure, lower is better because you're measuring the breathability, the transmission of the water vapor. Okay, just wanted to give you that for a comparison. Yes, the hood will feel a little warmer than a traditional hood, but it is not significantly higher when compared to your station, your turnout gear. What else was put in the certification? Well, in all hoods, there was always, they put in a new face opening test procedure, and that picture to the right is the equipment they use. You drop the hood face opening over that cone. It should slide down to the top ring, but not past it, and you should be able to pull down the hood to the second ring and not have any gaps in the face opening. That's a new test requirement, replaced using a tape measure to measure. It's a lot more accurate. There's also a strength test, a vertical flame test, a heat and thermal resistance test, a shrinkage test, thermal protection of the composite, seam strength, and thread melting. Those are all for all hoods, not just for particulate hoods. In addition, to meet the optional requirement for protective hoods, there's a particulate blocking test, which I covered earlier. 90% efficiency is the minimum, and a total heat loss minimum of 325 watts per meter squared. So the two additional requirements that have been added for particulate hoods are particulate blocking and total heat loss. Now, 1851 is supposed to be revised this year. I think they're still working on it, but it will include an increased laundering recommendation. It also will allow a hand washing for hoods if that's recommended by the manufacturer. And the task group is currently investigating various inspection methods, including visual and analytical methods, but nothing has been decided as of today. So the one thing we do know is there's going to be increased laundering recommendations for turnout gear and for hoods. Okay, one of the things I want to clarify about, you saw the way that the test was conducted for particulate blocking. It's a 6x6 swatch of the hood material, which is put in that testing equipment. So what I want to talk about is testing the protection system, the entire hood. How does the hood perform when it's combined with a full set of turnout gear? So it's going beyond the standard to evaluate the hood as part of a system. So here's the picture I showed you before. This is a traditional hood. put in what is called a FAST test in 2015. Now let me explain a little bit what a FAST test is, because I'm sure you've heard the term. It's called Fluorescent Aerosol Screening Test. In this test, the human subjects dressed in turnout gear, they go through 30 minutes routine of motion on their knees, crawling up and down stairs, moving around. They face one direction, turn face another direction, till they're all four. The particles in the chamber are the same size as specified in the NFPA test, between 0.1 and 1 microns. And you can see there's a lot of particles being blown around in that test chamber at a 10-mile-an-hour wind. So that's the basic function of the test. That's basically how it runs. You also have the option to do analysis beyond just qualitative, which is the picture with the fluorescent particles under a black light. You can do quantitative skin testing, in which specific areas are washed, the fluid's collected. That fluid is then, the fluorescence of that fluid is then measured, and then you can calculate a mass of the particles that penetrated in any given location. We chose to do this test. It's not required, of course. We sampled skin at 13 different locations, 7 on the neck, chest, ears, and in front of the ears below the temple. So first thing we discovered was that even with a traditional mask, proper donning is important. The picture at the left is the amount of particles that were passed through a hood, which had a slight gap, as you can see on the right, between the SCBA and the mask. That left a small opening for these particles to egress and get on the skin. So what we see, make sure, even if you're not wearing a particulate hood, that you have that hood properly sealed to your SCBA. Here's the difference between an improperly donned hood and a properly donned hood. These are both traditional hoods without particulate barriers. The one on the left is the one that was improperly donned with a small gap. The one on the right was properly donned. So just donning the hood correctly will make a big difference in the amount of particle protection that you get. So then we add a particulate hood in, and of course we tested our hood. The particulate blocking hood reduced the exposure from a properly donned non-particulate hood by a factor of 10. You can see the average concentration and the total mass that we measured at each of these locations. Traditional hood improperly donned, 265 micrograms. Properly donned, dropped that dramatically to around 39, and with the particulate hood, you're down around 2.5. So 10x exposure reduction with particulate hood. This did work. So we talked about the 1851 standard requiring more laundering. So we wanted to check and make sure that particulate blocking was still there. Was still there after 100 wash cycles. So we went through the entire FAST procedure again with a hood that had been washed 100 times. I can see once again, the hood dropped the particulate exposure dramatically from a traditional hood, even after 100 washes. So what are other factors to consider when you're making your hood choices? First one is, remember, neither a traditional nor a particulate hood is going to block water, blood, or viruses, and should not be considered protected from those threats. Secondly, is the hood certified to the 2018 edition of NFP 1971, the optional structural firefighting protective hood section of that certification process? Third, consider how often you plan on washing in the future. Has the effectiveness of the hood been evaluated for the entire hood after extended laundering? You also have durability considerations of the finished hood, including components, including the seams. Does your protocol at your firehouse allow for hood sizing, or does it align with one-size-fits-all approach if you're using a hood exchange program? And also there are inventory considerations that you have to manage if you are using a sized hood. Does the hood allow for easy inspection of the blocking layer to make sure you haven't lost the integrity of the protective layer? We talked about 1851 and inspection processes. They have not been defined. So one of the ways you can be sure that your hood is still providing protection after multiple uses is to be able to actually physically inspect the blocking layer. Other factors: what's the level of thermal protection required by your department based on your risk assessment? One thing to keep in mind is that unlike turnout gear, hoods are not tested for extreme flashover conditions. The protocol for flashover conditions requires that the test mannequin be suspended by the head, and so there's right now no way to measure the flash protection of a hood. What's a performance in a low heat flux situation? In other words, are you at risk of having hot water or steam type burns on the skin if the moisture is kept trapped next to your skin? What's the time difference between when you start to feel heat and when you actually are burned? Has the hood been evaluated as a finished product, or has the material just been tested to meet the minimum required standard? Again, the standard only requires the hood's materials of construction be tested, not the entire hood. Has the entire hood been tested using FAST on a live subject, and have the seams been tested for blocking smoke? One of the things that Gore does to go beyond the standard and make sure that what we sell is fit for use. We wanted to make sure that not just the material that the hood's made of performed to the standard, but the entire hood was protective. And that's why we did those tests.
I'd like to thank everybody for attending. I want to thank Gore for donating the hoods. And Jeff, thanks for presenting. Finally, I wanted to remind everybody that the recording will be available through the online classroom that can be accessed through nvfc.org. And once again, thanks everybody for attending, and have a good afternoon.
Thank you.